You just saw a video of chicken legs being dissolved in hydrofluoric acid versus hydrochloric acid. And you notice that it was more reactive inside the hydrochloric acid. And the reason is hydrochloric acid is stronger than the hydrofluoric acid. So the question is, well, how do we know and why is it that hydrochloric acid is a stronger acid than hydrofluoric acid? It has a lot to do with its structure. Okay, let's start with fluorine versus chlorine and going down the halogen group, the family. As you go down, do you know what trend is going down the periodic table in terms of the size? You're right. The atomic radius increases. So you can imagine these atoms getting bigger and bigger as you go down the periodic table. Do you know why it's getting bigger? Of course you do. It's because there are more energy levels, right? Well, if you have an acid, all of these are bonded to an H. Okay, as you can see, the hydrogen, this is hydroiodic acid, HI. This is the strongest acid of the whole list. Okay, can you guess why? Yeah, that's because the H is so far away from this I that the H will fall off really easily. Fall off very easily, causing damage to the chicken leg, causing it to burn. Okay, why do you think it falls off very easily? It's because the bond is so long that it is very weak. It's a weak bond. You guys agree with that? The electrostatic attraction is very weak when things are very far apart. Okay, as a result, this is the strongest acid. Okay, this table shows you this is the longest bond, and this is the bond strength. It is the weakest link between the H falls off and it burns you. This trend is for oxyacids. That means they're acids with oxygens. Sometimes they're also called ternary acids because they have different three elements. 1, 2, 3 different types of elements. As you go from one substance to another, there are 4 of them here. What is similar and what is different? Please pause your video. As you notice, they all have chlorine, and they also have oxygens. This one has 1 oxygen, this one has 2, 3, and 4. This one has 1 hydrogen attached to an oxygen, 1 hydrogen, 1 hydrogen, 1 hydrogen. This hydrogen that's attached to the oxygen is the one that's going to come off and be acidic and will cause to burn and damage and to react. The reason it falls off is because this oxygen is very electronegative, pulling electron density to itself, making this bond weak and causing the H+ to leave. Looking at this one has 2 oxygens to pull electrons away from the H. This one has 3 oxygens, and this one has 4 oxygens. Which of these do you think will pull the electrons more? Pause your video. Yes, of course. This one has the most oxygens, a lot of oxygen. And what that will do is it will pull electron density away from the H, causing it to leave. So the H+ leaves. When the H+ leaves, it causes acidity in the solution, which means of all these 4 substances, this is the strongest acid. So if they ask you in a ternary acid, which one will be the most acidic? Of course, the more oxygens, the more acidic. So which do you think is more acidic, HNO3 or HNO2? Pause the video, tell me which one's more acidic, and draw the Lewis structures. Do the same for H2SO4 and H2SO3. So here, since this has 3 oxygens versus 2, obviously this is the stronger acid. This one has 4 oxygens versus only 3. That means this is the stronger acid. And also notice that H2SO4 is diprotic, which means one H can come off at a time. I just wanted to show you, this is an organic acid, so you have the C double bond OOH. This is called a carboxylic acid, present in foods like vinegar. And because of the presence of the 2 oxygens, now you know they're pulling electron density this way, the hydrogen can come off and make the solution acidic.